Hello friends, welcome to my channel Pankaj Lade. Now in our today's session we are going to learn a topic called as sequence and series. Now sequence and series, some part you have already learned in your school in our lower standards. Now sequence and series is nothing but what? Now this topic, as I said, is quite important because it is going to come in your competitive exams as well. So you got to learn the topic conceptually. Now students, sequence and series, when I say what actually I mean by this is what you need to first understand. Now let us say when I say sequence, if I say sequence, what do I mean by a sequence? Now sequence is basically nothing but arrangement of numbers. You take some natural numbers or some other numbers, you take numbers and you start arranging them. For instance, if I write say 2, 4, 6, 8, 10 and so on. Now did you observe there is a specific pattern into these particular numbers? Are they all even numbers? They are all even numbers and they are all natural numbers. So what I have done here is I have taken all even natural numbers and I am writing those numbers in a sequence, isn't it? They are written in a sequence. So the arrangement of numbers one after the other is called as a sequence, isn't it? Now sequence, and when I say series, what do I mean by this? There's a very small difference between a sequence and a series. As I said, sequence is nothing but what? A specific arrangement of numbers. You start arranging the numbers, that is called as a sequence. Then if you keep adding these numbers, then that will be called as a series. For instance, if I write 2 plus 4 plus 6 plus 8 plus so on, then that will be called as a series. So students, sequence and series is basically nothing but what? A sequence is nothing but arrangement of numbers, and series is nothing but the addition of those numbers. So sequence and series. Now once we are clear with the basic definition of sequence and series, let's move ahead to understand different types of sequences. Now students, you have already learned something called as an arithmetic progression. This we have already learned in our school, isn't it? Lower standards. Arithmetic progression. The short form was AP. Now do you remember what is an AP? Now see, this sequence and series, this chapter, we are going to divide into small parts. In the first part, we are going to learn something called as the arithmetic progression. The second part, we will be learning geometric progression. The third part is going to be of harmonic progression. Students, these are three very important sequences that we want to learn. So there is an arithmetic progression, there is a geometric progression, and then there will be a harmonic progression. So our first session will be entirely based on arithmetic progression. So when I say arithmetic progression, what do I mean by this? Now so far you have understood that a sequence is nothing but what? Specific arrangement of numbers. Now did you see my sequence? In my sequence, the numbers that are written are 2, 4, 6, 8, 10 and so on. Are you noticing some kind of a specific arrangement, some kind of an interval between these numbers? Obviously, these numbers you can observe have a difference of 2. See, every time the difference is 2. That means between any two consecutive numbers, the difference is kept constant, isn't it? The difference is kept constant. So I can from here say that when the difference is constant, then the numbers, the sequence, that is what we have written, is called as an arithmetic progression, isn't it? So when I write a sequence in such a way that the difference between any two consecutive numbers is constant, then that sequence is called as nothing but a arithmetic progression. So basically progression is nothing but what? You have some kind of a specific interval. A specific interval has to come between any two consecutive numbers. Then that particular sequence will be called as a progression. And the first progression that we want to understand in our this session is the arithmetic progression. Now students, when I say arithmetic progression, as now you know that the difference has to kept constant, isn't it? Difference has to be kept constant. So I can write this one of the examples, say 2, 4, 6, 8, 10. I can write like this, say 3, then 7, then 11, and then 15, and then 19, and so on. Did you observe in the second example that I have written, the difference is kept again a constant, and the difference this time is how much? The difference is 4 this time, isn't it? You can observe that the difference is 4 over here between any two consecutive numbers. So if the difference is kept constant, then that particular progression will be called as an arithmetic progression. Now this arithmetic progression can be written in general as what? Observe. So if I write the first term, now this is a very important point you want to remember. Any progression will have something called as a first term. So the first term is A here. Now, if I say that the common difference is D, so students, what I did here, the first term is taken as A and the common difference is taken as small d. Then the particular progression now can be written as A. The next term would be A plus D. Then the next term would be A plus 2D. Observe, A plus 3D, A plus 4D, and so on, isn't it? So if you observe every single time, the difference is going to be kept constant. The difference is going to come constant. And what's the difference? The difference is D. Can you observe? A plus D minus A if you do. So A plus D minus A, you get D. A plus 2D minus of A plus D, again you get D, and so on. You take any consecutive numbers, you'll observe that the difference is always D. So the difference has to be kept constant when you're talking about an arithmetic progression. Now students, this is one very important thing you want to note down. This A is our first term, isn't it? A is our first term. Then A plus D is our second term. A plus 2D is our third term. A plus 4D is our fourth term, A plus 3D is our fourth term, A plus 4D is our fifth term, and so on. So now tell me, if I want to reach at nth term, now when I say nth term, what do I mean by this? Now most of the students have this one basic concept fit into their mind, is that nth term means the last term. Now this one point you have to remove from your mind. Students, when I say nth term, it does not mean the last term. Nth term is basically any term of the progression. Any term of the progression. So when I write A plus D, A plus 2D, A plus 3D, and so on. So nth term is basically any term of the progression. So now when I say the nth term, so let's say if I want to find the term over here, that's the nth term. Let's say the last term. So if I want to get the nth term, what could be the nth term? Should it be A plus ND? The nth term, should it be A plus ND? Isn't it? A plus D, A plus 2D, A plus 3D, and so on. So one might think that the nth term is A plus ND. Now students, this is where most of the people make a mistake. Nth term is not A plus ND. Very important thing. When I ask you the nth term of an arithmetic progression, it is not A plus ND. Observe carefully. Did you see the first term was A? Can I write A as A plus 0D? Isn't it? I can write the first term as A plus 0D. The second term is A plus D. Did you observe second term is A plus, can I write 1D? Similarly, the third term is A plus 2D. See, the third term is A plus 2D. The fourth term is A plus 3D. Are you noticing that when I say fourth term, I said 3D. Fifth term, you can observe it's 4D. Third term, it's 2D. Second term, it's 1D. First term, it's 0D. So can you now observe and tell me what could be the nth term? Absolutely correct. That thought has come to your mind, isn't it? The nth term is going to be A plus n minus 1D. This is very important formula, students. The nth term of an arithmetic progression is A plus n minus 1D. Now, this is one important thing. Again, you note down that when I say nth term does not mean the last term. It is not the last term. It is any term of the sequence. I want to get the 10th term. I want to get the 17th term. I want to get the 23rd term. I want to get the 51st term. Any term if I want to find, it is always given by this formula A plus n minus 1D. So when I say nth term, that impression should not come to your mind that it's a last term. Nth term is nothing but any term of the progression, of the sequence. So now I can observe that. Now students, let's what you can say, quickly revise the things that we have learned. Now the topic that we are learning is sequence and series. Sequence is nothing but what? Arrangement of numbers one after the other. Series is nothing but what? If you start adding those numbers, then it is called as series. The very important type of sequence that we want to understand is the arithmetic progression, the geometric progression, and the harmonic progression. In arithmetic progression, now when I say progression, what do I mean by that? When you have a specific interval between the consecutive numbers, specific interval between the two consecutive numbers, then that particular sequence will be called as a progression. The first progression that we want to understand is nothing but the arithmetic progression. In arithmetic progression, the difference always remains a constant, and then if I take the first term as a and the common difference as d, then the sequence, the progression can be written as what? A plus d, a plus 2d, a plus 3d, and so on. Then the nth term of the sequence, which is not the last term. Remember that nth term does not mean the last term. It means any term of the sequence, and that term is given by what? A plus n minus 1d. So students, Tn means the nth term for an AP is given by a plus n minus 1 d, where a stands for what? The first term of the sequence. D stands for what? The common difference of the sequence or the progression, you can say. And N stands for the position of the term. If you want to get the 17th term, N becomes 17. If you want to get the 23rd term, N becomes 23. If you want to get the 51st term, then N becomes 51. So N is nothing but what? It is the position of the term. So N is called as the position of the term that you want to find. So that's the formula for finding the nth term of an arithmetic progression. So students, now as we have seen the arithmetic progression, the formula for the nth term, the next important concept is to get the sum of these n terms. That means if I take the first n terms, a plus d, a plus 2d, a plus 3d, and so on, and if I add these terms, what could be the sum? So now if I'm going to write Sn, so Sn is nothing but what? It is nothing but a plus d plus a plus 2d, and so on till the last term, which is a plus n minus 1d. Now always remember, when I say last term, I actually do not mean the last term. It is nothing but any term of the sequence. So I have first term as a, the second term is a plus d, the third term is a plus 2d, and so on till the nth term. If I add these terms, I will get Sn. Now this sum is slightly confusing, slightly troubling, isn't it? To get the sum of all these terms, it will be slightly difficult for us. So instead of taking the sum like this, a plus d and a plus 2d, let's try and get it by a simple technique, a simple way. Now, do you know that a is the first term? So I write t1. Then a plus d is the second term, so I write t2. Then the third term t3, and so on till the last term, which is tn, the nth term, which is tn. So this is nothing but Sn. Now students, I'm going to call this as equation 1. Now this is t1, t2, t3, and so on up to tn. Now if I reverse these terms, do I get the same thing? Tn plus tn minus 1 plus tn minus 2, and so on till t1. Now before tn, if you remember, there will be what term? There will be tn minus 1, isn't it? Before t1, what term will be there? There will be t2, isn't it? So now what I've done here is, equation 1 is nothing but sum of the n terms of an AP. So there is t1, t2, t3, and so on up to tn. Next thing what I did, I have simply reversed the terms. That means I have written first t1, then tn minus 1, and so on till t1. I have simply reversed the terms. That's my second equation. Now students, you got to understand this very carefully. Both of them are Sn, isn't it? t1, t2, t3, and so on up to tn. t1, t2, t3 up to tn. Both of them are nothing but Sn. Now make a point of this. Suppose I'm going to write one sequence. Let us say 2, 4, 6, 8, and 10. I'm restricting this sequence to 5 numbers. There is 2, 4, 6, 8, and 10. Now if I reverse these numbers, see what do I get? 10, 8, 6, 4, and 2. So what I did simply is I have reversed the terms. 10, 8, 6, 4, and 2. Now if you try and get the sum of these numbers, was it t1, t2, t3, t4, t5? This is t5, t4, t3, t2, and t1. Let's try and get the sum of these numbers. So if I take t1 and t5, so t1 was my first term, t5 was my last term. If I add them, what is 10 plus 2? That's 12. Let's go ahead. Let's take t2 and t4, isn't it? So t2 was my second term and t4 was my second last term, isn't it? t4 is my second last term. So t2 plus t4, if I do, what's 4 plus 8? It is 12. Again, if you take 6 and 6, again it is 12. Again 8 and 4, again it is 12. Again 10 and 2, again it is 12. So did you observe that if I add these two equations, if I add the equation 1 and 2, Sn and Sn will become 2Sn. Then I get T1 plus Tn, T1 plus Tn. Then I get T2 plus Tn minus 1. See, what was the sum here? This T2 and T4, when I added, I got 12, which is same as T1 plus T5. Then 6 plus 6, which is T3 and T3, or 8 plus 4, which is T4 and T2. Every time the sum is coming what? 12, which is T1 and T5. So T1 plus Tn if I do, or if I do T2 plus Tn minus 2, or if I do T3 and Tn minus 9, and so on, if I keep on continuing further, I always get the sum as what? T1 plus Tn. That means T1 plus Tn was my first sum. T2 plus Tn minus 1. Again it is going to give me what? T1 plus Tn. Then T3 plus Tn minus 2. If I add these two terms, again what do I get? I get T1 plus Tn, and so on if I keep on continuing till the last term. Did you observe the last term is again coming what? T1 plus Tn. Now, how many times have these terms repeated? So this was first term, second term, third term, and so on. This was my nth term. That means all these terms which I have added have come how many times? They have come n number of times. So I can write n number of times of T1 plus Tn. So students, did you observe? I've got 2Sn is equal to n into T1 plus Tn. That means from here I can say Sn is going to be n upon 2, then a bracket T1 plus Tn. Now do you remember what was your first term? Your first term was A, and your nth term was A plus n minus 1 d, isn't it? So if you simplify this, n upon 2, A plus A is going to be 2A plus n minus 1 d. So students, that's your formula for sum of n terms of an arithmetic progression. Now, you can memorize this formula in two different ways. The first way obviously is Sn is equal to what? N upon 2 T1 plus Tn. So T1 stands for the first term and Tn stands for the nth term. And the other formula that you can remember is Sn is equal to n upon 2 and a bracket 2a plus n minus 1 d. So now so far what things we have covered? We have covered what is sequence, what is a series, what's an arithmetic progression, A the first term, D the common difference, how to write the sequence, how to get the nth term of the sequence, isn't it? Now when I say nth term, you have to remember that nth term does not mean the last term. It simply means the any term of the sequence. Any term of the sequence is nothing but the nth term. And the formula for getting the nth term was A plus n minus 1 d. Then further we have gone to get the sum of these n terms, the sum of the first n terms of an AP. The sum of first n terms of an AP, two formulas we have learned. Sn is equal to n upon 2 T1 plus Tn, and Sn equal to n upon 2 2a plus n minus 1 d. These are the two formulas for finding the sum of first n terms of an arithmetic progression. Now students, one last point you want to remember is to introduce one term between two terms which are in AP. Understand carefully. I said introducing one term between two terms of an AP. Now this is called as an arithmetic mean. So that's one last point that you want to understand when we talk about arithmetic progression. So students, now if I want to get something called as an arithmetic mean, I want to get arithmetic mean. So let's see what is an arithmetic mean. Now it simply means if there is T1, T2 and T3, I am taking only three terms, T1, T2 and T3. Then the middle term T2 simply becomes an average of the extremes. That means T2 can be written as T1 plus T3 upon 2. That is nothing more than arithmetic mean is. Now let us try and understand this with respect to the terms. So let us say there is A, the first term, the next term would be A plus D, and the next term would be A plus 2D, isn't it? A plus 2D. Now if I take the first term which is A and the last term which is A plus 2D and I add them and take the average. So I've taken the first term A I've taken the last term a plus 2d. I've taken only 3 terms here. So a plus a plus 2d, and I took the average of the 2 terms. So if you observe, a plus a is going to be 2a plus 2d upon 2. The answer comes what? A plus d. Is it nothing but a middle term here? That means if there are 3 numbers, I want to call them in an arithmetic mean. If there are 3 numbers which are in arithmetic mean, then the middle term will be an average of the extremes. So in general, if I call the numbers as ABC, let's call the numbers as ABC, and I'm going to tell that ABC are nothing but what? They are arithmetic progression terms. Then B is called as an arithmetic mean of A and C. So B can be given as A plus C upon 2. So basically arithmetic mean is nothing but what? It is the sum, or it can say it can be the average of the extremes, isn't it? So if A, B and C are 3 terms, and I'm going to tell that B is an arithmetic mean of A and C, I simply mean by what? B is equal to A plus C upon 2. So that is what the basic concept of arithmetic progression is. So students, I hope you have understood very well what is arithmetic progression. Keep watching my further videos. In the next video, I'll be taking what is a geometric progression, and obviously we will be looking at some questions also. So students, thank you so much for watching. Have a great day ahead.